Hi, so I have a problem on the board. We have a cubed equals a squared minus b squared, and we have to find all integer solutions. It's actually going to be positive integers. So we need to find all positive integer solutions for a and b. And so we're just asked to find, we're expressing a cube number as a difference of squares. So to start with, we'll mention that a cubed is going to be the same thing as 512, and a difference of squares can be factored as a plus b times a minus b. So then with a plus b, with a and b being integers, we know that each of these numbers are integers, so we're essentially turning 512 into a product of two integers. So we could just plug in, we could do something simple like check 8 squared times 8, because multiply that together, that's 8 cubed. But we want to find all integer solutions. So we want to look at all possibilities of this expression. So what I'll do instead is I want to get the prime factorization of 512. So let's, instead of looking at 8, let's look at what 8 is actually 2 cubed. And 2 cubed is actually 2 to the 9th. And then the good thing about that is, okay, so we only have 512 is just made up of a single prime. So breaking up the prime factorization into a product of two numbers is pretty simple. So we can just kind of create a little table for our a plus b, a minus b. So yeah, let's make it like, we just want all possibilities of this. So we could have 2 to the 9th times 1. We could have 2 to the 8th times 2 to the 1, which is just 2. 2 to the 7th times 2 squared. 2 to the 6th times 2 to the 3. Let's say I should actually, let's actually write in the values. This is 512. This is 256. Oh no, I'm having a hard time writing. This is 128. This is 64. Then we could have 2 to the 5 times 2 to the 4. This is 16, and this is 32. We could have 2 to the 4 times 2 to the 5. But actually, you'll notice we run into a problem here because a plus b has to be greater than, it's always greater than a minus b. And then here we have 16 and 32. And so that doesn't make sense because we end up saying that a plus b is greater than a minus b, which is impossible. Because at the beginning we said we're only looking for positive integers. And so we can just stop at that and just look at these 5 cases. Okay, so next we have these possibilities and we want to solve for a and b. So what I'm going to do is I think I'm going to clean up the board and get more space. Okay, so I have on the board, I have the, I've created this table of all possibilities from the prime factorization of 512. And now we want to check each of these answers and solve for a and b. So to start with, we'll look at this first case when a plus b equals 2 to the 9th, or 512. And a minus b equals 1. We add these two equations together, b's cancel, we get 2a equals 513. Divide both sides by 2, and we get a equals, what is that? 256.5. And what we're gonna do is we're gonna reject that because we need only integer solutions for a and b. So what we've done, we've introduced this problem where we need, in these type of problems, parity, the odd even of both these has to be the same. You can see that we're going to be fine here because all of these have the same parity. They're all even numbers. So then we're not going to run into the solution here, but here we're end up adding even number to an odd number, and that's not going to work. So we'll eliminate that as a case. So next we'll look at this 2 to the 8th times 2 case. So when a plus b equals 2 to the 8th, which is 256, and a minus b equals 2, we'll add these together. B's cancel, 2a equals 258, and then that's going to be a equals 129. And then to solve for b, let's just use this second equation. I think it's going to be a little easier. So we're going to say 129 minus b equals 2. So that means b equals 127. We'll just fill in that in our table here. We'll do a quick confirmation. 129 squared minus 127 squared is 16641 minus 16129, and that difference is gonna be 512. So let's move on to the next case. When a plus b equals 2 to the 7th, which is 128, and a minus b equals 2 squared, which is 4, we're gonna get, just adding these together, we're gonna have 2a is gonna be 132, but that means a equals 66. Then we'll use our second equation again. 66 minus b equals 4, so that means b equals 62. Plug that into our chart. Do a quick confirmation. We don't need to do this part, by the way, it's gonna work, but I just like to do it to be sure I didn't make a mistake. And that, yep, that's 512. So let's go on to our next one. What happens when a plus b equals 2 to the 6th, or 64? A minus b equals 2 to the 3, or 8. This, by the way, is actually kind of the easy one because we can always break 8 cubed into 8 squared times 8, and that is always kind of a quick solution, but we need to find all solutions. So again, adding these together, 2 to the 8 equals 72, a equals 36. 36 minus b equals 8. So that means b is going to be 28. Let's do a quick check. 36 squared is 1296 minus 28 squared is 74, and that's going to be 512. So we have that. And then we need to just check our last case, which is going to be 2 to the 5th times 2 to the 4th. So that's going to be, we're saying a plus b is going to be equal to 2 to the 5th, which is 32. And a minus b is 2 to the 4th, which is 16. Adding those together, we get 2a equals 48. So therefore, dividing by 2, we have that a equals 24. But then we can use this equation just to find our b. We already know a. 24 minus b equals 16. So that means b equals 8. We'll do a quick check. 24 squared minus 8 squared is going to be 576 minus 64, and that is going to be 512. So we'll plug that in. So pretty nice. We get our 4 solutions, right? Our 4 solutions for a and b. And this will be all solutions. Wow, that's a rough squiggly line, but those are our 4 solutions, and I'll stop it there.